Okay, these are the notes for 11-6, the surface area and the volume of a sphere. All right, a sphere is basically like a basketball or a globe here. This top picture here with some of the basic vocabularies, the center is the center. And like a two-dimensional circle, the sphere has the same vocabulary words. The line that goes all the way across is the diameter. Radius, of course, is halfway across. This line that goes around the circle is called the circumference. Now, when you look at a sphere in the three-dimensional world, you can think that there might be more than one circumference, and there technically are. Like there's maybe a circle up here, maybe a circle here. But when you see any bookwork and they say, hey, the circumference is this, they're only talking about the circumference right in the main area where the radius reaches. And that is also going to be called the great circle, which is a crazy definition, but that's what they're going to call it. Going down to the second picture here, this one is the hemispheres, where it is either the top half of the sphere or the bottom half of the sphere, basically half a sphere. And this one here, where they are pointing to right in the belly of that thing, that again is called the great circle, which the book will just call the circumference. But once in a while, they'll bump into the word great circle. All right, the two main formulas of the day, the surface area of this guy. If we were going to paint the outside of this ball, it is 4 pi r squared. All you need is the radius. When you look at a sphere, there's only one measurement that it really does have, and that is a radius. It doesn't have a height, doesn't have a base, doesn't have an apothem or anything like that. So it's just based on the radius. The volume, how much air can be put in this basketball? How much liquid can we put in this globe here? This is going to be a very unusual formula. It is going to be 4/3 pi r cubed. Okay, before we go on to problems 1 and 2, you're going to need a calculator. And based on this volume formula here, we've got some unusual numbers that we got to get into a calculator. We're going to need the number 4/3. You can either create a fraction. You're going to need this button right here, this ABC button here. You punch in 4, the numerator, then ABC, then the 3. Or if you don't have the ABC button, you can go this route, 4 first, and then you can hit divided by 3. And then it will turn it into a decimal, but it's still the same result. That's how you get the 4/3 in the calculator. The other main idea here is we've got something to the third power. So if I'm, for example, say that the radius is 5, and I want to take 5 to the third power, which basically means 5 times 5 times 5, you got to first punch in the number 5, and then you're going to look for one of two buttons on your calculator, depending on it. This is the exponent button. It looks like a YX, or some calculators will have this kind of upside down V here. This is, again, the exponent button. After that, you punch in the number 3 if you're going to take it to the third power, and it should equal 125. If you don't have either one of these two buttons, you might have to go 5 times 5 times 5 3 times. But you look for these buttons here, the ABC button for the fraction or division, the YX, or the kind of the upside down V, which is the exponent button. Okay, we're going to do number 1 here. It says find the surface area and the volume of a spherical melon with circumference of 18 inches. So I'm going to just give myself a picture. To draw one of these spheres, to make it look three-dimensional, you just draw a regular circle. And instead of just drawing a line, to give it three-dimensional, you kind of got to give it like a belly. And then behind it, you're going to make a dash, dash, dash line, a belly the other direction. Okay. This guy has a circumference of 18 inches. What we're going to need for the surface area, which is a formula, 4 pi r squared, or the volume, which is 4/3 pi r cubed, we're going to need the r, the radius. How far is it here to here? And so we're going to use the circumference to figure out the radius. Circumference formula is, of course, 2 pi r. So we're going to replace the circumference with 18, 2 pi r. We're just going to divide both sides by 2 pi here. Not only divide by the number 2, but also pi. And this turns into a little bit of an ugly number here. The radius is 2.86 approximately. Okay. From there, we just use this 2.86 to figure out the surface area, plug it in here. Also, to figure out the volume, plug it in here. So real quickly, it would be surface area, this new formula, 4 pi r squared, 2.86 squared. Surface area, with the calculator's help, is 103.1. This is inches squared, a two-dimensional concept area. Volume, the new crazy formula, is 4/3 pi r. Radius is 2.86 cubed. Again, you might need these buttons here for 4/3. You might need this button down here to figure out something to the third power. But when you throw all of this in the calculator and multiply by the pi symbol, you should get 97.9 inches cubed. Okay? Okay, and finally we're going to go to number 2, and we're going to really need your calculator here. The volume of the sphere is 4,200 cubic feet, and they want to figure out the surface area. Well, the surface area formula is pretty simple. It's 4 pi r squared. Of course, what we need is the radius. And we're going to work the problem backwards. And here is the volume formula. Since we have the volume, it is 4/3 pi r cubed. We're going to try to figure out the radius. We know that the volume is 4,200, 4/3 pi r cubed. Let's solve for r. We need to get rid of all the numbers on the same side as r, so let's get rid of this 4/3 by multiplying by the reciprocal 3/4. Multiply both sides by 3/4. When you take 4,200 and multiply by 3, then divide by 4, you end up with 3,150. 4, 4, 3, 3, that goes away, pi r cubed. Then I don't want this pi symbol here, so I'm going to divide both sides by pi. And my running out of room here. This is approximately 1002.7 after you divide by pi r cubed. I'm actually going to erase this for just a second here. Now we've got a problem. How do we deal with this, getting rid of this 3 up here? We're basically going to, if that was a 2, we would take the square root. But now we have a 3 here. So what we're going to do is take what, instead of the square root, we're going to take what is called the cube root. We're going to take the cube root, that's a 3, of both sides. For the right side here, the 3 and the 3 we're just going to cancel out. But how do you take the cube root of 1,207? You're going to need a calculator. First thing you're going to want to do in your calculator is hit 3. Well, at least most calculators, this is the way it should be. Then you want to go second. You want to go to the second button. Hit either the YX. Oops, that's not the YX I'm looking for. It would look like this. YX, or that upside down V. And then punch in 1002.7. Okay, so it's going to be, use these buttons again, but you're going to need the second mode of it, the second mode. And you should, if you do this correctly in the calculator, you're basically telling the calculator what number times itself 3 times is going to be 1002, and it should be basically 10. It's going to be 10.0001, something to that effect. But it's basically 10 because 10 times 10 times 10 is 1,000. And so this is really close to 1,000. So it's just going to be over 10. It's 10.001, but we'll just go with 10. So the radius is 10. And then from there, you plug it into this formula, 4 pi r squared, plug in the 10, and then this should be 400 times pi, approximately 1,000 or 12, 1,256.6.